Hello everyone, and welcome to our webinar, Introduction to the Automotive Core Tools. My name is Gus Oliveira, and I'm an International Marketing and Market Analysis Manager here at SoftExpert. Today's webinar will be presented by Mr. Paul Hardiman, who is recognized globally as an expert in automotive quality management and has over 35 years of industry auditing and training experience. I wish you all a great webinar.
Hello, my name is Paul Hardiman. Welcome to this video on the introduction to the automotive core tools. So the automotive core tools are promoted and used within the automotive industry, and particularly they're used within the framework of the automotive specification IATF 16949-2016. And the goal of that specification is about continual improvement, defect prevention, and the reduction of variation and waste. The tools that we're going to take a look at today are Advanced Product Quality Planning, which is known as APQP, Failure Mode and Effect Analysis, FMEA, Measurement System Analysis, MSA, and Statistical Process Control, SPC. And these all accumulate into a document called the Production Part Approval Process, which is known as PPAP. Now let's take a look at some of the requirements in the IATF 16949-2016 specification. We will see within the specification there are now clear requirements that internal auditors clearly understand the application of the automotive core tools. And also that same requirement applies to people that are going out to undertake second-party audits. These are audits that are being undertaken of an organization's suppliers. So now let's take a look at some of the requirements in the automotive specification, IATF 16949. I know some of you watching this video will be internal auditors. Internal auditors now have to demonstrate an understanding of the automotive core tools, because I guess IATF think if they don't, they're not going to be able to undertake effective audits of the processes within their organization. There is also now a similar requirement that people that are going to go out and audit an organization's suppliers, which in the standard are called second-party auditors, also understand and can apply the automotive core tools. Now within the framework of IATF 16949, there is no specific requirement to use advanced product quality planning. The standard says that we can use advanced product quality planning when we go about introducing new products, but equally we can use project management. Whichever technique we use, we have to demonstrate that we're using a multidisciplinary approach, and within the team of people that are being used, the team have the necessary competence in the automotive core tools. We will see within the framework of IATF 16949 that there is a requirement that people understand basic statistical concepts. So anybody within the organization that is collecting data, analyzing data, and using data statistically, they have to demonstrate they have the relevant statistical knowledge to be able to interpret the data effectively. So we will also see within the framework of IATF 16949 that people within the organization that are collecting, analyzing and using data, particularly where they're using data in a statistical way, that they need to understand the relevant statistical concepts and how to correctly interpret and analyze the data. We also see within the requirements that there is a clear requirement related to measurement system analysis. So for each type of measuring test equipment system that we use within the organization, that we evaluate the variation within the measurement system statistically. There is also a requirement about customer-specific requirements. Now, whereas IATF 16949 promotes a set of common automotive requirements, different automotive customers will promote different automotive tools, but not just the different tools, the different acceptance criteria for using those tools. The final thing is there is a requirement for the organization to demonstrate that they have an effective process at the end of the new product introduction process to demonstrate that their process has the capability to meet the customer requirements. In automotive speak, that is called a part approval process. So now let's take a little bit more of a look at the tools in a bit more detail. The first tool that I want to have a look at is Advanced Product Quality Planning. I don't want to make this too complicated because I think Advanced Product Quality Planning simply works on a plan, do, check, act cycle. And it is a structured way that we can go about introducing new products and processes within the organization. The first phase of any new product introduction should be to plan and define. So this is making sure that we have a clear understanding about what we're setting out to achieve. The second phase of Advanced Product Quality Planning is the product and or the process development. This is making sure that we're developing a product that meets the customer requirement and that we're developing a manufacturing process that will meet those customer requirements in a volume manufacturing process. Once we've come up with the product and the process design, we then have to make sure that we validate the design to make sure that it meets the customer requirement. And the accumulation of that will lead us in to the production part approval process. This is where we submit the documentation to the customer to make sure that the product and the associated manufacturing process is capable of meeting those requirements. But Advanced Product Quality Planning does not stop there. It is an ongoing process of continual improvement and also focusing on defect prevention. How can we make processes more likely to produce less defects? What can we do in terms of our continual improvement process? So now let's take a look at the tool FMEA. Now we will see within IATF 16949 now that there is far more emphasis on understanding the risks within the organization. Now what FMEA does, it looks at the potential risks of things going wrong related to the product design, if we are product design responsible, and it also looks at potential things that could go wrong within the manufacturing process. And from the results of the risk analysis, we do an assessment of risk using 3 key criteria. We rank risk from a severity point of view, an occurrence point of view, and a detection point of view to give us something called a risk priority number. And obviously the higher the risk priority number, the higher the risk, and this can help us focus on where we need to either modify the product design or we need to modify the process design to reduce the risk of things going wrong. And in the automotive industry, it's been proven that if FMEA is used correctly, it can actually reduce the risk of product recall and defects being produced while the vehicle is out in the field. So the next thing I want to take a look at is the thing called a control plan. Whereas with failure mode and effect analysis, we think about risk, we also think about what are the necessary controls that we need to either put in the measurement of the product within the manufacturing process or how we are actually going to control the manufacturing process. Somehow we need to capture that as an output of the FMEA, and we need a mechanism to capture that and communicate it to people working within the manufacturing process. The way that's done in the automotive industry is all those controls that are coming from failure mode effect analysis are a direct input into developing this thing called a control plan. Once we develop the control plan then should link to the work instructions that are needed to perform each of the specific tasks within the manufacturing process. So obviously, once we have designed what we need to measure either on the product or within the manufacturing process, we need to make sure that we have the right measuring systems. Now, obviously, the first thing we need to make sure is that any equipment that we're using for measurement is calibrated. But in automotive, they say just calibration alone is not enough. What we do need to understand is the variation in the total measurement system. So obviously, the measurement system results that we get can be influenced by the people that are making the measurement. They can be influenced by the environment, they can be influenced by the parts that we're measuring, and really in very simple terms what measurement system analysis does is it tries to analyze the variation in a statistical way within the total measurement system. So an example would be if people are using a micrometer, they might not all be using it in exactly the same way. So what we do is a measurement system analysis study to analyze that variation. So now let's take a look at statistical process control. Now it may be when we go through the risk analysis using the FMEA that we decide, because of the criticality of the parameter that we're going to measure, for instance, it may be a special characteristic that is going to have an impact on the safety of the product we're producing, that we need to proactively understand the variation within the process and be very proactive in taking action if we see any change or drift within the process. So the tool that we use to actually analyze the output of a process in these cases is statistical process control. And for example, if we visit the shop floor, statistical process control would normally be seen by statistical charts, which would be there to monitor the variation within a process. So now we have been through the new product introduction process. We have done our product validation, we have done our process validation, we have run the manufacturing process at the required rate. Now what we need to do is to provide the customer evidence that our process is capable to meet their requirements. And the customer requires documented information that that has been done effectively. So the way in automotive that works is the organization will be required to provide information in a structured format to the customer. One of those structured formats is called the production part approval process. So this is really a format of bringing together all the relevant documentation and information that we have created through the new product introduction process and put it into a structured format. So for example, the production part approval process would include the failure mode and effect analysis, it would include the control plan, it would call measurement system results, and it would also include statistical data, including process capability. So what I've talked about so far is a series of separate automotive core tools. But in practice, that's not the way that it should work. All of these tools should clearly link together. So what we should see is that the design FMEA links into the manufacturing process flowchart. The manufacturing process flowchart should link to the steps in the failure mode and effect analysis. The output of the failure mode effect analysis should link into the control plan, and then the control plan should show us what measurement systems we're using, where we're using statistical process control, and then there should be a link to the standardized work or the work instructions that are used to directly control the process on the shop floor. If as part of new product introduction we don't ensure these linkages, one, maybe the new product introduction process is not going to be effective, but two, we are leaving ourselves very open to non-conformities either in internal audits or when the third-party certification body come to audit our organization. So really, this is something that we need to look at within our organizations to make sure that all these tools and techniques fit together, and people that are responsible for the different tools and techniques understand how they should all fit together.
Thank you all for taking part in this presentation. If you have any questions or would like to get in touch with Mr. Hardiman, please email him at increase@qualitypartner.co.uk. Mr. Hardiman has also released a series of online training videos about automotive core tools. If you're interested, please visit the link available in the description of this video. Also, check out SoftExpert solution for the automotive sector, a complete software that can help you in the automation of all of these tools presented by Mr. Hardiman. For more webinars, please visit our website at www.softexpert.com. See you next time.